Excellent. All right, guys. How do you find the slope of a line? What's the formula? So we can do it either way. Usually we write it this way, but it doesn't matter. We can do it both ways. And really that's because this is m, which is also, the way we remember it is rise over run. Or the fancy way, delta y over delta x. You know, delta from science. Change. Change in y over the change in x. Amazing. All right, what's a tangent line? A line that touches the graph once. And a secant line? Twice. There we go. All right, obviously it's not a graph that touches the graph twice. It's a line. Maho, quiet. We're going to draw a picture to help make sense of this because there's a couple of things we need to do. When you first learned these, you probably learned them with circles, which is why your definition was like it touches it once or twice, right? But here's the reality. If we have some kind of curve, and then I have like a point here, and I do a point of tangency, I get an oops. This is the point that matters. This is my point of tangency. Yes. Yes, miss. Yes, miss. Okay, so that's the tangent line, and it actually ends up hitting it again. So in other words, what we're doing is we need to like localize it and say, hey, at this area, it only touches it once.
Wouldn't that be a secant line?
Nope, I literally just explained that. Okay? No, you were here. I literally just explained it. Okay, so this one here would be a secant line, and once again, we get like an oops. So basically, you have to kind of define where you're looking at it, and that's what's important. You might have it touch more than once or twice, but really, you're like localizing it to an area, and that's what you're focused on. So here, these would be my points of secant. Let's call it secantry.
No, sequency. Why is
Secancy?
Are you making up terms?
I'm totally making stuff up. Secancy. I think it's secantry.
I don't think so.
We're gonna look it up later, but all right. For now, it's secant. So the point is, when you did it with a circle, there was no way for a tangent line to cross it more than once. When we have some kind of curve, it is possible, but we still focus it in and localize it on that one little point. Okay. All right. Excellent. Esteban, join us, man. Grab a seat. Grab a seat. All right, now let's go into what we're actually going to look at. That was all necessary, but now we're going to like apply it. So we've got this thing called the difference quotient, and we're going to start with another picture because we love pictures. Look at this beautiful picture here. Then,
Sorry, can I borrow Julia for an interview for journalism?
it's up to her. This is one of the hardest lessons she's going to have all year.
No. Pero
She said no. Come back
I
later.
said yes, but like this
Oh,
is hard.
you can go.
No, mister.
I don't recommend
I don't
it.
want to lose another text.
All right, good. So you're going to draw our curve, f of x. It's some form of a quadratic. I mean, if you want to make it look more like one, just extend it further. Okay? Then we're going to put in our 2 points. Try to steal you from class, me too. And this would be like our secant line. What?
Oh my god. That's big. No.
Why was that?
I'm just kidding. All right, so this would be the point,
Wait,
x, f of x.
Our first student we examine one of the most concerning concept of calculus. You can say that.
Yeah.
Doesn't matter. Mister, my sister, never mind.
Guys, we're drawing a picture to help illustrate one of the things that are concepts we're going to spend the greatest amount of time on. Yes, okay? So, this would be x, f of x, which means that this point here is just x. Now, what if I made this like fictitious distance here, h? Then what would this point here be? X plus h. Which would make this point x plus h, comma, f of x plus h.
What? No.
What? No, think about it.
No, what the hell?
All we did, like, we always write our points x comma y, so x f of x. Down here, my x is x plus h. So that would mean that my y is f of x plus h. It makes perfect sense. We're all happy about this.
Puede ser
So in this case, x is not like the
X is x.
Music, can you explain again?
X is not like a point in the
It is. X is just some point on the graph. Keep watching, it'll make more sense, guys. All right. For now, I don't know. If this is giving you a hard time, if you're having trouble with some, I don't know, parameterization. What? I didn't tell you to leave the class.
Nobody's saying that.
Because you guys told me last time that I say that all the time.
I mean, you say it to me. I know you don't want me in this class.
That's not true.
Actually, for you, I am here.
Julia, I want you in this class.
Maybe.
All right. Now, guys, what is the expression f of x plus h minus f of x over x plus h minus x represent? The slope, right? This is literally y2 minus y1 over x2 minus x1. So that is literally just the slope of the secant line. Now, what does it simplify to? Is there anything on there that can be crossed out? Yep.
H plus
No.
y2.
No. X minus x. Hell yes. So now we've got f of x plus h minus f of x all over h. This should start to look like something I made you do last unit. And now, if we say, what if we took h and made the distance between those two x values approach 0? In other words, what if we take the limit as h approaches 0? What would happen? No.
That means that it will be 36.
What happens if all of a sudden my secant line only has 1 point?
Tangent.
It's a tangent line. It would literally turn it into a tangent line. It would become a tangent line. Right? If that distance gets infinitely smaller until it becomes 0, it's just a tangent line. So therefore, what does the limit as that distance between the 2 points becomes 0, or approach 0, of f of x plus h minus f of x over h? Remembering that this was a simplified form of what? Of the slope. So then this would become the what? Slope of what? Slope of the tangent. Right? We already had the slope of the secant line. That was the original one. Now if we take the limit as h becomes 0, it's the slope of the tangent line.
Okay.
Amazing. Guys, this is like the whole point.
So if we understand this, we're understanding everything.
I mean, you're going to understand everything until like January. Then we'll do integration. So, but yeah, no, this is like the main concept we're going to spend from now until like January. What?
In the last semester, can we bring food and eat here?
Oh yeah, we right before Christmas we do an assignment where you guys are you're gonna optimize something using calculus and you're gonna fill it with treats and then we'll watch a movie. You did the simplified version, yeah. Now we're gonna do the hard version. Exactly. All right, so let's actually practice this because here is our function and we want to find the slope of the tangent line. You might say, but what tangent line? There's so many of them. You'd be right. But let's just find them anyway. So the limit as, nope, not x, h, approaches 0 of, now it's, remember, it's f of x plus h. So this is going to be negative x plus h squared minus 4x plus h plus 1. Now how good are you guys? Do we need parentheses here or can we distribute the negative 1?
No, sir. No, because you have to apply that ninja.
All right, so let's apply the ninja, which is negative 1. So minus negative x squared is actually plus x squared. Minus negative 4x is really plus 4x. And minus 1 is minus 1. All over h. Okay, chill out. Take a look. Now, is there anything on there that you can get rid of right off the bat? And you can be like, no, go away.
That 4x.
Uh-huh. Not the 4x yet, no.
That one.
The
A
ones.
negative one.
Absolutely, right? 1, -1. Those are going to cancel. I wonder if they can still hear me in the video.
And then you have to take h out of the equation so that you can cross it out with the bottom one.
That is what we're going to have to get to, exactly. So we're going to get rid of this 1 and -1. Now let's keep going. The limit. How good are you guys at your algebra?
I'm amazing. Amazing.
So, Mr.
Okay.
Isn't the same as what we read, like similar, no?
It is very similar. That's what I said. I gave you all that stuff earlier on purpose. Okay? So, x plus h squared. You guys are experts, so you know that it's x squared
Plus
2xh.
plus h.
Now, why did I not write pluses? Because there's a negative I'm going to distribute. And rather than writing it out twice, I thought it was easier to just do that, right? Because it's -1 times all those things. Would you agree?
Yes.
Yes? Okay. See, you guys are great. Then hang on, then we got to put in the -4. So -4x, -4h. Rewrite the rest of the equation, plus x squared plus 4x, all over h.
Wait.
And then take a look at it. What else happens?
These are, did you, wait.
Alright.
I'm waiting.
You get the 4x and the 4h, you separated them.
Oh, we cancelled that x.
Yeah, because I distributed the -4 in.
2 and plus x to 2.
So look, x squared and -x squared, those go away. -4x and 4x go away. Now, we'll write this in 2 steps, but normally it's okay if you want to do it in 1. But for now, we'll do it in 2, because we've already skipped quite a few algebraic steps. So this is going to be -2xh minus h squared minus 4h all over h. But really, if there's an h in everything,
We could just cross out the h.
yeah, so I'm going to rewrite it the long way this time. So pull out that common factor of h, -2x, minus h minus 4, all over h.
And we can cross that out.
So we killed the h, which is what we wanted, because the thing on the bottom was the issue, right? When I plugged in 0, we divided by 0, and that doesn't work. Now we're not doing that. So what's my next step once I've simplified the problem? Plug in h equals 0. So this just becomes -2x. Do I need to write -0?
No.
No. So I can just say -4. Amazing.
And that's it.
That's it. We are done. Okay?
Sir, can you wait for me?
I am waiting. Does anybody know what that's called?
That is
It is called a derivative. Okay, so your results to the previous limit is defined as the derivative. We write it this way a lot. It means f prime of x. F prime of x. That's what that means. It's not f of 1 or f of negative. F prime. Prime means it's the derivative.
Oh, yeah, I hate that. Cousin.
Okay? Now let's see what the derivative represents in terms of the graphs of f of x. Well, it is the slope of what?
Limits of 0 or with the derivative?
Of the tangent line.
Vamos.
Sir, Brad, can I ask you a question?
Yeah.
So when we were finding limits of zeros of different functions, like all this time we were doing the derivatives. So
If you took the limit as it approached 0. Like only if we take this specific limit. And later I'm going to show you
but it
easier
has to be
ways.
a double-sided limit. It cannot be a one-sided.
Yeah. All right. Let's actually prove the statement we just made. Let's prove it because you guys are new to this. So this is that same graph. And now we're going to find the value of the derivative, f prime of x, when we plug in different x values. So this means that f prime of -4 is going to be -2 times -4 minus 4. What is -2 times -4? -4? Exactly. So 8 minus 4 is... I would like you to write all of that, because otherwise you're going to forget it later, man.
Where did that -2 come from?
Because I'm literally taking the derivative right here.
Oh,
Okay? Then we're going to do it again for -2. F prime of -2 is -2 times -2 minus 4, which is 0, right? -2 times -2 is 4. 4 minus 4 is 0. I meant to write that one in pink. You guys don't have to rewrite it, but I'm going to quickly rewrite it because I like doing it in colors for you here. So f prime of -2 is equal to -2 times -2 minus 4 equals 0. And then our last one we'll do in green. F prime of -1 equals,
2, -2.
all right, so -2 times -1 minus 4, that's 2, right? -2 times -1 is 2, minus 4 is -2. We're going to start with the easiest one, and we're going to actually draw out these tangent lines and see if we're correct. So this is the easiest. At -2, right here, right, I need to draw a tangent line. I'm starting with that one because it's the easiest, right? What's the slope of that line? Definitely 0, right? Slope of a horizontal line is 0. Okay, so that one definitely holds true. Let's try this next one. At -4, so this point, I need to write a tangent line. You guys can do this easier. You have a ruler. You're just going to slide, like your ruler's here, and you're going to slide it towards it until it only touches the point at -4. I can't do that. I got to be a little bit fancier. That doesn't look like it. Ooh, that looks good. No. There we go. I got it. So it should look roughly like that. Now, if I find the slope of that tangent line over 1, rise of 1, 2, 3, so this is a slope of 4, right? 4 over 1. So it seems to be holding up that the tangent line has a slope that is equal to the derivative. What's that? What?
That's true.
That's the tangent line, and the slope is 1. Well, you use your ruler. Just slide your ruler towards it until it only touches the tangent. 4. Let's try the next one. Now we're going to -1. And if I put that one in, the slope of that is -2 and 1, so -2. So it would appear that yes, indeed, right, the slope of the tangent line is the derivative at that point. Well, guys, you have a ruler. You get it easier. You have a ruler like over here, and then you just move the ruler in until it only touches that one point. For you, it's even easier. I have to like.
No, because like it looks like it crosses, but it doesn't. Again, because the marker is too big.
Well, maybe your marker's too big. I don't know, work on your penmanship. I promise you that this is true, okay? I promise. No, it doesn't have to be perfect. It doesn't have to be perfect. Make it as close as you can. All right. So we already did this part. It says use a ruler, right? And put in those things. We just did that. By investigating the graph, what does it appear that the derivative of the function represents in terms of the graph at given values of x? Well, we already said this, but let's write it out. So we said that f of x, or f prime of x, sorry, is an equation that can be evaluated to determine the slope of any caps tangent line drawn to the graph of f of x for any value of x. Why am I saying any? I'll let you write it down, and then I want you to think about why am I saying any? Any tangent line for any x. Because it's a function, right? If we look at it, it has an x in it, meaning that wherever I want to find the slope of the tangent line, I just plug in the x coordinate, right? The x like is the map that tells me where to go look. So if I want the slope at -5, I literally plug in x equals -5 and I get the slope. If I want to know it at x equals 1,000, I put in 1,000 and I'll get the slope when x is 1,000. Okay? So that's why we're saying it's for any tangent line at any value of x. Now let's write down what the definition of the derivative is then and what it represents. So we're going to write this out as the I'll do it in blue, sorry. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Because we just talked about that, right? That's the slope of the tangent line. So what does it represent then? Well, the tangent line, so let's write that out. F prime of A represents the slope of the tangent line drawn to the graph of f of x at x equals a. This is a little bit hard to see in here, but there is. I'll try and separate it so you can see it better. There you go. There's the prime, right? So f prime of a, the derivative at a, represents the slope of the tangent line to the graph of f of x whenever x is a. A is just a parameter. Last time we used c, right? It just means like somewhere in there, some parameter. Good so far?
Yep.
Anybody feeling lost, or are we okay? Kind of lost? Does the concept at least make sense that if we like take 2 points and shrink the distance between them, that eventually we're going to get a tangent line? So because we now know how to take limits, we can actually do that, and we can make that distance between them become 0. All right, let's try and actually apply this a little bit, because we've already come up with, what was, so our f of x, if I remember right, actually let's write it. Yeah, no, f of x was negative x squared minus 4x plus 1, I believe.
Yes.
And f prime of x, when we found it, was negative 2x minus 4. Now we're going to define 2 more things for you. Something called the pot and the side. You know what these are. What's the pot? Do you remember? Point of tangency, exactly. So in other words, this is just a f of a, right? Just xy. The SOT, that is our slope of tangency. So this is f prime at a. Take the derivative at that same value. A f of a. It's just the pot, the point of tangency. Okay, this is the point of tangency, and this one here is the slope of tangency.
So the equation for the tangent line slope will always be negative 2x
For this equation only.
for every tangent.
Only this equation, but every tangent on this equation, yes. So let's find the equation of the tangent line. It means that I need my point of tangency, and I need a slope. And then I can figure it out, right? Because I need a point and a slope, just like we've always had when we did lines before. So my pot is negative 4 and f of negative 4. So just in case you're having a little bit of a hard time, we'll at least do the first one together. F of negative 4 is going to be negative negative 4 squared minus 4 times negative 4 plus 1. What's negative 4 squared? Good. And then times negative 1 is negative 16. What's negative 4 times negative 4? 16. So negative 16 plus 16, 0. So it's just 1. So my pot is negative 4, 1. Right? I was just plugging in negative 4 into the function. That's all. My SOT is quite a bit easier. This one is where I just need to find f prime of negative 4. Pot and SOT? Yeah, because these are the ones that we've been using, right? Right? That's the same function. We're just doing the same one. Okay. No. I don't remember what they're called. Things when your throat's sore. Soup something? I don't remember the name. Anyways, f prime of negative 4 is going to be negative 2 times negative 4 minus 4, which is 4. It should literally be what we found earlier, right? So that's why next time I'm not going to like show all the work, okay? Because we've literally done these up above. Okay. To write out my equation, we go y minus y1 equals the slope x minus, so minus 4, so x plus 4, because it's, right, minus x1, so minus negative 4 would be plus 4. Now, I can leave it like that. in calculus, there's nothing wrong with me leaving it in that slope point form. If you would like to simplify it and write it this way, that's also fine. I don't care. They're both correct. They're both just the line. You got confused on how to take what? Which part? So remember, the form is y minus y1 equals mx minus x1, right? That's our slope point form. That's how we write the equation of a line. Okay, now, equation of the tangent line at x equals -2. We'll do this one a little bit quicker because, you know, like I said, we're copying information from up above. So my pot is -2. Then I'm going to plug it into here and get 4, -4, plus 8 is 4, plus 1 is 5. Okay, if you have a hard time with that, that's okay. Slow it down and put it in there, but you're just literally plugging -2 into f of x, remember. My SOT, I'm not even going to spend any time on because we literally did this up above. It was 0. And so then I write my equation, y minus 5 equals 0, x plus 2. But really, if my slope is 0, this whole side goes away, and I'll just get the line y equals 5. Now, this is the one time where I would say don't leave it like this, because you're more likely to screw it up later then. It's not wrong. But like with these ones where you have a slope of 0, simplify it to y equals a number, okay? Don't leave it in that slope point form. Just this one. No, like these ones, I would actually never simplify these, because later you're going to see that we're going to do a bunch of approximations, and it's easier if you leave it in slope point form. Okay? Yeah, try the -1. I'll write it, but you guys just look up if you need help. Try and do the next one on your own. Okay, so try it on your own. Once you're done, look up, see if you got it right. What did I do with what?
Oh wait, no.
What do you need help with, ladies?
No.
I have a question.
Yes.
In the formula for x, the first, like the x squared is negative.
Yep.
Plugging in a negative value, that becomes positive.
So it's -1 squared, which is 1, times -1. Saying negative x squared, if there's a negative inside the x squared, is like basically having 3 negatives. So that's why it stays there. It's a good question, though. What about... No? How many people tried it on their own and got it?
No, I didn't get it.
2 of you? 3 of you? 4 of you? Okay, guys, it's hard. It's hard. It's okay if you didn't get it on your own.
Sir, I understand how to do it, but why it need the same time like
Well, we're gonna do the next little part and see if that helps you, okay? Any questions about that one? Any questions? Good job. All right, so let's keep going then. So, what have we basically done? What do we need to like consolidate? Huh? Yep. Good. No, I don't care which way. Leave it this way. Leave it this way then. You didn't actually write the line. Okay, so here's the thing, guys. When you hear the derivative, you should think. When you hear derivative, you should think what? Slope of the tangent line. When you hear slope of the tangent line, you should think. Right. So when you think derivative, that was terrible. When you see derivative, good. When you see slope of the tangent line, when you hear derivative, when you hear derivative, when you hear slope of the tangent line, when you hear derivative, that's okay. Wasn't great. All right. They don't even send anybody running anymore. My first 2 years, they sent people like, "What's going on?" No, it's nothing. Oh well.
You do that
every not abusing those.
I do it every year. Every year. All right, so last time we had at least drawn out this or written out this, right? So what we had to do is just plug in x plus h into our x, and then we had to subtract the entire function, okay? Then we put the entire thing over h. Then I'm going to need to expand this, which I almost should have done when I first wrote it down because it's so easy. But, oh well. So we're going to get 2/3, or 2x times 3, plus 2h over 3, not times, I apologize. Actually, I can already get rid of something. What could I cancel out already? Exactly. Let's get rid of those 3's. I don't want to write out extra stuff. All right, and then the whole thing's over h. What can I get rid of now? Amazing. And so that leaves me with 2h over 3 over h. But what's an easier way of dividing fractions by fractions? Multiply. Exactly. Keep, change, flip. And now what happens to those h's? Goodbye. So, well, what happens if you have 2/3 minus 2/3?
Oh wait, I didn't write.
Okay. So the limit as h approaches 0 of a constant now, because everything's gone, is a constant. So the answer to this guy is just 2/3. And remember, what does that mean? That is equal to f prime of x, right? Because that's what we're learning, is that is the derivative. And I yelled at you last time, and then you yelled back at me, and it was great. What? You don't remember? I yelled at you, and you yelled back? I don't want to repeat it. My throat's sore today. All right. I'm all right for now, but thank you. Can we do the next one?
Yeah.
Excellent. So, if I'm doing this, that means all I got to do is take the limit as h approaches 0 of 1/2 x plus h squared minus 2x plus h plus 3 minus the whole f of x, so minus 1/2 x squared plus 2x minus 3. Now, why did I flip the signs? Because I'm subtracting, right? If I'm subtracting the whole function, the easier way to do it is just to immediately distribute that negative and cancel it all out, and then the whole thing's over h. Now, you guys are experts at algebra, so I believe you can do x plus h squared, a perfect square, all at once. So, it would really be x squared plus 2xh plus h squared, but then really I'm multiplying it by 1/2, so that would mean that I'm just going to take all of these and divide them by 2.
What?
Right? Because I'm multiplying it by 1/2 as well. Are you okay with that?
Yes.
Have we panicked, or are we all right? Right, it was x squared, then we multiplied it by 1/2 to get x squared over 2. It was 2xh times 1/2 is just xh. And then h squared times 1/2 is h squared over 2. All right, we're amazing. Now, minus 2x minus 2h. Before I even write down this 3, what should I have probably done? Get rid of the stuff as soon as I can so I don't have to keep writing extra stuff. All right, and then minus 1/2 x squared plus 2x all over h. Does anything else cancel?
Yes, that's 2x's.
Yeah, okay. Negative 2x, positive 2x, what else?
X squared divided by 2.
Yeah, x squared divided by 2 and negative x squared divided by 2.
Yeah.
Now the only thing that's left is stuff with h's. So I get xh plus h squared over 2 minus 2h. And instead of dividing by h, I can multiply this whole thing by 1 over h, right? Keep, change, flip. What's up?
Cancel the x squared over 2.
You guys, the same thing, right? I wrote them different, but part of the reason I do that is to make sure you guys understand what things are equal and what
The
aren't.
properties.
Exactly. I want you to know properties. Look at that. Look at you go. All right, then I'm going to multiply by 1 over h. So again, that means I need to distribute this 1 over h into everything, which really means it's just going to cancel an h. So this is going to become x plus h over 2 minus 2 And that's still going to be the limit as h approaches 0. What's my last step of a limit once I've simplified it? Plug it in, man. X plus 0, don't bother writing that, so it's just x minus 2, and that is equal to my derivative. Don't we all feel smart right now? Why not? I'm doing what now? I'm doing it also. You don't feel smart? Okay, fair enough. Well, because what if h is 0, what's 0 over 2? So then it's x plus 0 minus 2. Do I bother writing the 0? I know. I love it when I'm right.
Why did you take away like 1/8 and multiply that by the 1 over h?
Because h over h is 1, h squared over h is h, and h over h is 1. And I just didn't bother writing the 1s. All right, let's take a look at this real quick here. Okay? Emilio, not while I'm talking, man. So f prime of x for the linear function was what? What did it become? For this one, f prime of x became what? Look on your page. 2/3, which is a constant. Here, this was a quadratic, and what was your derivative? What kind of function? Linear function. So what does it seem like is happening? Yeah, we're taking away 1 degree. So it appears that the degree of the derivative is 1 less than the function. So if I had an original equation that was cubic, what do you think the derivative would be? Yeah, 2, right? Squared. If I had a constant, what do you think the derivative would be? 0. Right? 0. It makes sense if you think about it. What does a line look like for a constant? Like, what is the graph of a constant? Just a flat line, right? What's the slope of a flat line? 0. Makes sense, right? Checks out. All right. Let's try some tougher examples. Y'all ready? We're going to do some fun stuff. All right. So here, we're going to take the limit as h approaches 0 of the square root of x plus h plus 2 minus the square root of x plus 2 all over h. What do I need to do? All I did is write x plus h. Let's chill out, man. I don't change any signs yet. Somebody over at that table said it. Conjugate. So remember, that means that it was not you ladies. So I'm going to write out the exact same thing, except what's the difference? I changed the sign to plus. Only that sign between the two.
What did I say? I changed the sign.
Yeah, but you said change the signs. Plural. You only changed one sign, dear. And to be fair, I didn't say you were wrong. I just said not yet. Well, no, I don't know. I wasn't talking to you. I was talking to Julia. Because when I'm doing this limit, I have to plug x plus h in wherever there's an x. Now, here's the wonderful thing about the conjugate and the reason we do it and the reason we love it. I cancel out the square roots. So this literally just becomes x plus h plus 2 minus, now be careful, let's use parentheses since you guys often mess this part up, x plus 2. All over, and this is the part that's a little gross, x plus h plus 2. Yeah, it is a little gross, I agree. All right, that. Then I can start simplifying my numerator. What's x minus x? What's 2 minus 2?
Cancel.
So what's left on the top?
H divided by h, so what remains of
Exactly. So really, I'm going to be able to cancel those, and I've just got 1 over. Now let's write out the rest of it still here. The square root of x plus h plus 2.
You replace the 0 with
plus the square root of x plus 2.
And then we insert.
Now I can do exactly, we can actually do the substitution part. So I plug in 0 and I get 1 over square root of x plus 2 plus the square root of x plus 2. And yes, what did you say it was there, Elias? Sorry.
1 over 2 times the square root of x plus 2.
Good. And that is equal to my derivative.
Wow.
I know, aren't we amazing?
It's not
Nah.
She said, why cancel the H out? Did you take the H's out of the
Oh, I didn't take them out. This is an h and then it became 0, right? We're doing the substitution.
No, wait.
No, wait! I don't want to!
As it would be.
We're going to start the next.
Wait, what happened?
Okay, guys, here's the thing. I have no problem answering your question. Hang on. Let's pause it first.
Did you do that?
All right, we've dealt with our questions. Well, they weren't really questions. All right, so the limit as h approaches 0 of 3 over x plus h plus 2 minus 3 over x plus 2.
Divided H.
All right. Oh, yeah, all divided by h. Thank you. All right, so I got to deal with this. Like, this numerator is ugly. We got to fix it. Do you need help? What's up?
Just asking for help.
I think we're good. The numerator's ugly. How do I make it less ugly?
Cross multiply, mister.
Kind of.
What?
Yeah, so it's not really that. What we're doing is we need a common denominator. So we're going to multiply this by a really fancy looking 1. And then we're going to multiply this one over here by a common denominator as well. So another really fancy looking 1.
We mister, what the heck?
No, look, I'm just multiplying this one by x plus 2, this one by x plus h plus 2. Because I want a common
But
denominator.
the common denominator is adding the H.
But you can't, I can't just add an h.
Mister, what if we just cross multiply to make put together the fraction?
Because that's not technically what you're doing mathematically, and I don't want to teach you a cheap trick. But
trick.
yes,
Cheap
you
trick.
can use that cheap trick if you want. Just know that you're mathematically doing something
But
wrong.
I'm going to but mister, hear me out. I cross multiply for the numerator, and then I multiply only the denominators together.
I know what you're doing. It's a cheap trick, and that's what I'm saying. It's fine. I'm just not. I agree. And if I was doing scratch notes, I would do that too. But I'm not going to write it this way when someone's looking at the example. But I agree with you. The cheap trick is okay. Yes. All right, guys. I'm going to distribute it at the same time. So 3x plus 6. I'm going to distribute these at the same time too. So negative 3 times x is negative 3x. Negative 3 times h, negative 3h. Negative 3 times 2, negative 6. All over x plus 2, x plus h plus 2. And I'm going to take care of this like fraction of a fraction at the same time. So how do I get rid of this division by h?
You multiply like
By 1 over h, which really means I'm just going to shove the h in the denominator, right?
sure.
Right? Like if I'm multiplying by 1 over h like this, it's probably easier for me to just write it here. Means the same thing. Would you agree?
Yeah.
Good. Let's save ourselves some time. Now let's simplify. Cross out 3x, negative 3x, 6, negative 6. And technically now that I've done that, what else is going to cancel?
H.
Yeah, so I'm going to write it out this time just to make sure that we don't confuse anyone.
Wait, negative 3. Mr. Negative 3, go.
Be like that.
Well, I don't know. Sometimes you guys get confused. Last time, Mariana had a little bit of a conniption when I did it. And this is the limit as h approaches 0. So I'm going to get rid of those h's. At that point, if I've gotten rid of those 2 h's, that means that I can just plug it in, right? There's no longer a problem on the bottom. So I can just plug it in. Negative 3 over x plus 2 times x plus 2. And just for Ariana, what is this now?
2.
No, x plus 2 squared. I gave you your opportunity.
Yeah. I understand because the other one was plus and this one is times.
How did you write it?
Ah,
That's
man.
¿Por qué multiplicar?
H is 0. It goes away.
No, yes, I ate, but like the other one you expanded it.
All right, so the last thing we're going to do here is find our tangent lines. Now, luckily here, we already found our derivatives. So the two things we need whenever you see tangent line, Esteban, you should be listening. Ariana, Julia, you should be listening. So the first thing I need when you see tangent line is your plot. So that's going to be 7, and then I'm going to plug it into f of x. What is the square root of 7 plus 2, or the square root of 9? 3. Then I need to find my SOT. Now my SOT is f prime of 7. And if we look up, we can see what our f prime was. It's right here. So it's 1 over 2 times the square root of 9, because 7 plus 2, right? No, you got lost with 7 plus 2. Oh, dear Lord. We broke her brain. I'm finding, look, I need pot and SOT, always. Point of tangency, which is 7 and f of 7. I need the SOT, the slope of tangency, which is f prime of 7. So I plug in 7 into the derivative. 1 over 2 times the square root of 9, which is 1 over 2 times 3, which is 1 over 6. Once I have that, I write out my equation. Y minus y1, which is negative 3, or 3, sorry, equals 1/6, bracket, x minus 7. Now again, you could like simplify it. I don't recommend it. It's easier to leave it this way because we're going to do estimations later, and they're easier to do if it looks like this, in my opinion. So we're going to be like, that's the equation of the tangent line. All right, so the next one. What are the two things I need whenever we see tangent line? Pot and SOT. My pot's easy. I'm going to just do 1, and I'm going to plug in 1 up here. What's 3 over 1 plus 2? Look how good you guys are. Now my SOT, let's do that off to the side here. So f prime of 1, zoom up so we can see it, would be negative 3 over 1 plus 2 squared. Because I'm literally using the derivative, right? Negative 3 over x plus 2 squared, and I'm just plugging in 1. What's 1 plus 2? 3 squared? Negative 3 over 9? Good, negative 1/3. All right, so my SOT is negative 1/3. It's kind of an ugly 3. Let's fix it. And then I just write my equation. Y minus 1 equals negative 1/3 times x minus 1. Do we all feel good? Do we feel great?
No.
Really? I actually don't, you shouldn't simplify this usually because this is a more useful form when we do estimations, so, which we'll get to, so you can always leave it like this. So this is just the form. So that's a specific form where we write y minus y1 equals m x minus x1. It's a slope point form, I think it is. Yeah, no worries. Guys, I'm not going to use the graphing calculator right now. I can help you with it later if you want. But basically, you can use the graphing calculator. Let's see here. Graph each of the functions above in the equation of the tangent line to verify you found your work. I mean, I can do one, I guess, if you want. All right, let's do one of them. Do I have? Oh, I don't have Desmos open. I gotta open it. We'll do one of them quick. I won't do both, but we'll do one. So the first function was square root of x plus 2, right? And then we wrote the equation of the tangent line, which was y minus 3 equals 1/6 x, I forgot, minus 7, thank you. Now, when we look here, these two equations should only touch once at the point of tangency, and it should be at 7. So let's zoom in a little bit at 7 so we can kind of see this. That's the only place they touch, right? Why at 7? Because that's where we force the point of tangency to be. Okay? All right. Last thing before we're done then, guys. You can check the other one on your own to make sure it worked. This is a little bit annoying. It cut off the equation here. This here should read negative x squared minus 4x. Oh no, was it plus 1 or minus 1? It's the first equation we worked with. Plus 1. And the equation of the derivative for that, if we look it up, was negative 2x minus 4.
Are we supposed to memorize?
No, guys, we did it earlier. We're not memorizing anything. You just did them earlier, and so I'm writing it down for you. But if you look back in your notes, look, the very first one we did. Look. I'm not just making up random stuff. No, look at this. Here it is, and then we found the derivative. So all I'm doing is copying it down because we already did it. That's all we're doing. Well, I did write down the equation, both of them. I know. It's crazy. I did what I said I would do. How insane is that? Or is it insane that you don't expect someone to do what they say they're going to do? It is insane. All right, so now let's look at this. The value of f prime of x at the indicated value of x. So at x equals negative 1, that means that I'm going to go negative 2 times negative 1 minus 4. Negative 2 times negative 1 is 2. Minus 4 is negative 2. I agree. Then let's find the value of this particular limit. All right, this is new. We haven't done this. The limit as x approaches negative 1 of f of x, which is negative x squared minus 4x plus 1, minus f of a. Meaning, let's use some parentheses to make it easier on us. This is going to be negative 1 squared minus 4 times negative 1 plus 1 all over x minus negative 1.
Wait, sir, what did you draw right there?
Minus negative 1 squared. Minus negative 1 squared. All right. Then I'm going to simplify it. Negative x squared minus 4x plus 1 minus negative 1 squared is 1 times negative 1. Oh my goodness, so much messiness. Plus 4 plus 1 all over x plus 1. Then the top. Negative x squared minus 4x. This is going to become, let's see, negative 1 plus 1 is 0, plus 4 minus 4, 1 minus 4, negative 3. That's a lot of crunching of numbers there. I did not write this small enough either. I feel bad. I really should have made way more space for this question. Like, there's no reason. It's just blank space. Oh, no, it isn't blank space. Okay. I thought it was. I still should have made more. It's okay. It's okay. We're going to get there. Can I factor the top there? I can. So I could do the limit as x approaches negative 1 of negative 1 times. How good are you at factoring? Right? If I factor out the negative 1, then I've got x squared plus 4x plus 3, which is x plus 3, x plus 1. And then those two things cancel. And so then I get the limit as x is approaching negative 1 of negative 1 times x plus 3. Then I just plug it in. What's negative 1 plus 3? 2. Negative 1 times 2? Negative 2. Samesies.
So I have a question.
Yep.
Factorial. I don't know how to do it. You change the sign to express.
Can we try the next one? All right. We're just copying down what we already had before. This one was 1 over 2 times the root of x plus 2. When I plugged in 7, I believe we just got 1 over 6. Good. Now we're going to take the limit as x approaches 7 of f of x, so the square root of x plus 2, minus f of a, so minus the square root of 7 plus 2, all over x minus 7. Now, realistically, what is the square root of 7 plus 2? 3. So what I'm going to do is I'm going to have to multiply this by a conjugate, which is ugly and annoying, but it's what I'm going to do. The square root of x plus 2 plus 3 over the square root of x plus 2 plus 3. Okay? When I multiply the tops, that's our difference of squares that we created. So it's x plus 2 minus 9 over x minus 7 times the square root of x plus 2 plus 3. Are you all with me still? Yeah. Yeah? Then I can simplify that top, right? What's x plus 2 minus 9? And what is x minus 7 over x minus 7? It's going to cancel. So I'll write it out a long way for you here. Square root of x plus 2 plus 3. Now those x plus 7s, or x minus 7s cancel. And now that I've gotten rid of the problem, can I just plug in 7? So I'm going to get 1 over the square root of 7 plus 2 plus 3, which is 1 over square root of 9 is 3 plus 3. Hey, look, samesies. I'm going to show you. So, what this is a much less useful, in my opinion, because it's usually less efficient, way to find the derivative. So what inference is this? Well, we just saw that it was equal to the derivative at the point. So what this is this is literally the slope of the tangent line of f of x at x equals a. So it's a specific derivative at a. Why is this one less helpful? Because it only gives me the derivative at that value, 7. What happens if I want the derivative at 2, 3, 4, 5 places? Well, then I want the equation so I can plug in my different x coordinates. So this is arguably more efficient if you only need one. Realistically, you guys, you're not going to use it very often. You're usually going to just find the other one and then plug it in, okay? The only time realistically you're going to need to use this is when the College Board forces you to because they ask you a question about it, okay? So I will ask you a couple to help prepare you for that, but I'm not going to use it a lot, especially because later the whole point of this is to learn other ways of doing the derivative that are faster and easier. There's other ways, we'll talk about them later. Yes. And if you're in this class, they're going to test you on it. So let's talk about what these two things are then. This is the definition of a derivative. This is a function called the derivative that can be used. I just realized that this video is going to be noisy. Shoot. I didn't realize that window was open. That video is going to have a whole bunch of wind going through it now. Oh well. That can be used to find the slope of the tangent line drawn to f of x. This is what we would call the general derivative. General because it has, like it's a function, right? It has variables in it. This one, the alternate form or the derivative at a point, this is a value that is the slope of the tangent line drawn to f of x at x equals a. This is a specific derivative. And that's it.